LWO1 WeatherNet. Liftoff conditions looking pretty good.
CSTS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8.
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good afternoon. It's Thursday, June 17th, and on your screen is a live view of Falcon 9 as it awaits its 12:09 p.m. Eastern Time launch from Cape Canaveral Space Force Station in Florida. My name is Yomezo, and I'm a propulsion engineer here at SpaceX. Welcome to our webcast coverage for GPS-3 Space Vehicle 5 for the Space Force, SpaceX's 19th launch this year. GPS, originally developed by the U.S. Air Force and formerly known as the Global Positioning System, is a constellation of orbiting satellites that provide precise position, navigation, and timing data to military and civilian users globally. The U.S. Space Force continues to provide this free service to more than 4 billion users worldwide. For many of today's viewers, GPS services aren't new. If you're like me and have ever used your phone's mapping service or retrieved coordinates for a location via a pin drop, then you've received information from a satellite within this system. Collectively, with the system's already operational satellites, the payload today will further the U.S. Space Force's ability to provide mission-critical global access, persistence, and awareness for our national security. Before we dive deeper into learning more about the GPS satellite and its capabilities, let's take a closer look at the vehicle on your screen. Falcon 9, our two-stage liquid-fueled launch vehicle, is in position at Space Launch Complex 40. Now, while the booster supporting today's mission is flying for the second time, today marks the first time that SpaceX is supporting a U.S. Space Force mission with a reused booster. And to top it off, this particular booster debuted right here on Slick 40 for last year's GPS-3 Space Vehicle 4 mission. Now, if you're new to our webcast or are unfamiliar with the Falcon 9, what you see at the bottom two-thirds of the vehicle are soot markings from its previous flight. These markings are located on what we call the first stage. The first stage's primary role, with the help of its 9 Merlin engines, is to accelerate the vehicle all the way to the edge of space, where it will then drop off the second stage carrying the payload. Following its drop-off of the second stage, the first stage will make its way back to Earth, where we'll attempt to recover it on our autonomous drone ship. Just read the instructions, which you can see there. Now, if you turn your attention to the section above the first stage and the black carbon fiber inner stage, you'll see the Falcon 9's second stage. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single MVAC engine to carry the GPS satellite to a highly elliptical orbit. Separation from second stage will then occur, and then the satellite will perform burns. Finally, above this stage, placed at the very top of the vehicle, you'll see this nose cone structure called a fairing. Inside that structure is where the GPS-3 satellite is currently sitting. The two fairing halves are safely encapsulating the satellite to protect it from aerodynamic heating, loads, and contamination during ascent. The fairing halves we are using today are new, and we'll recover them using our chartered recovery ship, HOS Briarwood. Once the fairing reaches the vacuum of space, we will jettison the fairing halves as the second stage continues on its journey to orbit.
Good morning from SpaceX headquarters in Hawthorne, California. I'm John Innsbrucker, Falcon Principal Integration Engineer. The launch vehicle and satellite vehicle teams are ready for launch as we approach T-minus 10 minutes, 45 seconds to liftoff. This is our 4th GPS launch, and all 4 have been from Space Launch Complex 40. Now, earlier today, the satellite team performed functional checkouts of the GPS satellite, and the satellite went on internal battery power at T-minus 15 minutes. The Falcon 9 team began their final checks at T-minus 2 hours, and most recently, we completed the pull to proceed with propellant load and launch. This was at T-minus 38 minutes, and all parties were go. Now, the team at Cape Canaveral began loading propellant on time at T-minus 35 minutes. A Falcon 9 is a bipropellant vehicle. That means it uses 2 propellants, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need an oxidizer. Now, most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there's no atmosphere to provide oxygen or other oxygen-bearing molecules, so the rocket needs to carry its own oxidizer to space. And in our case, our oxidizer is super chilled liquid oxygen, referred to as densified LOX. The liquid oxygen is chilled well below its boiling point, and that increases its density, which allows us to load more into the first and second stage LOX tanks. Now, currently, fuel loading is complete on the second stage. Fuel loading is continuing on the first stage for another few minutes and will wrap up at T-minus 6 minutes. The liquid oxygen loading is continuing on both the first and second stages, and you can see the gaseous vapor coming off of both tanks as that ultra-cold liquid oxygen contacts the skin of the vehicles and the floor to air. Now, in addition to its propellants, Falcon 9 also needs an ignition source to start burning the fuel and oxidizer. And for that, we use the chemical T-tub that stands for triethyl aluminum and triethyl borane. Now, when it's fully fueled, Falcon 9 first and second stages combine to carry over 1.1 million pounds of propellant. And we're going to burn through most of that over the 8.5 minutes it takes to land the first stage and get the second stage into its initial orbit. Now, once our Merlin engines begin to burn RP1 kerosene and the liquid oxygen, you're going to see the rocket throwing that combustion exhaust out of the engine nozzles in one direction, and that results in a push on the rocket in the opposite direction. And this is a great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. On the weather front, at T-minus 1 hour, we were down to just 10% probability of violating launch weather requirements. The only thing we've been looking at is upper altitude wind shear. That looks good right now, so we expect we're going to be good for the last 7.5 minutes of the countdown. Weather conditions are also looking good for the booster landing on our drone ship and for the fairing recovery. So with that, the launch vehicle, satellite, the weather, the range are all good to go for a 12:09 p.m. Eastern liftoff from Space Launch Complex 40.
As we mentioned earlier, today's GPS-3 Space Vehicle 5 mission is for the U.S. Space Force. This mission will be SpaceX's fourth overall GPS-3 mission. 2 missions were successfully launched in 2020 and 1 in 2018. And following today's launch, we are planning our 5th mission for sometime next year. To date, these next-generation satellites provide increased signal accuracy and reliability to operate even if confronted by cyber adversaries. Not only does GPS-3 help with national security, it also enables all facets of our daily lives. To learn more about the constellation, take a look at this video by the Space and Missile Systems Center, which provides critical national security space capabilities to the U.S. Space Force.
Stage 1, RP1 load closed out.
It is T-minus 4 minutes, 35 seconds. Everything continues to be go for launch. We've had a quiet countdown throughout the morning. Now on your screen, you see the large structure next to Falcon 9. That's the strongback. At any moment, the strongback will begin opening the 2 clamps around the second stage. You can kind of see them obscured a little bit with the LOX vapor. The strongback retract sequence has begun. Now, once the clamp arms are open, the strongback will retract away from the rocket slightly, just under 2 degrees. And then as the Falcon 9 lifts off, the hydraulic arms will pull the strongback farther away. Get a little bit of the view as the arms come open. Next step now is the strongback will begin to recline away from the Falcon 9. There's not much motion, but you can see we're getting a little bit of gap opened up between the strongback and the Falcon 9. Now the strongback is part of the transport erector. That's called the TE. The transport erector is used to roll out Falcon 9 to the launch pad, raises it to the vertical launch position, also routes power, fluids, and communication to both the rocket and the satellite. The TE includes both the launch mount that the first stage is clamped to right now, and the strongback, which is hinged to the launch mount. Next major event coming up at T-minus 3 minutes is closeout of liquid oxygen loading on the first stage.
Stage 1 pogo bleed.
We're closing out liquid oxygen loading on the first stage. Falcon 9 and GPS teams are continuing to track no issues for launch. The weather continues to look good. The range is ready to support. The SpaceX team is monitoring completion of LOX loading on stage 2. That's due to finish up at about T-minus 2 minutes. And as a reminder, if we have to call a hold on today's launch, we have a backup opportunity tomorrow with a liftoff time of 12:05 p.m. Eastern.
Stage 2 LOX load closed out.
And we've got confirmation. Stage 2 LOX loading is complete, and that completes loading of the over 1.1 million pounds of propellants on the Falcon 9. All systems remain go for launch. Right now, we are beginning to drain the propellant out of the lines that go up the strongback to the second stage, and that's creating the large white cloud you see around the strongback. Pressure from that ultra-cold LOX line is vented overboard, and it meets up with the warm, moist Florida air. Now our next event will be startup called out at T-minus 1 minute. At that point, the first and second stage computers on Falcon 9 are executing stored programs to prepare the rocket for flight, leading to ignition of the Merlin engines at T-minus 2 seconds and liftoff at T0.
Falcon 9 is in startup.
Falcon computers are running the final sequence for launch. We're also pressurizing first and second stage tanks for liftoff pressure.
CMD is go for launch.
We've heard the call out. The Space Force mission director is go for launch. T-minus 33 seconds and counting. All systems go for launch.
30 seconds.
Let's listen into terminal count and watch as Falcon 9 transports the U.S. Space Force's GPS-3 Space Vehicle number 5 satellite into orbit.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff. Go Falcon, go GPS.
Vehicle is pitching downrange.
Stage 1 chamber pressures are nominal.
T plus 36 seconds. SpaceX launch engineers report nominal conditions on Falcon 9. We begin the trip to space carrying the GPS-3 satellite. Merlin engine's about to throttle down. We're in the throttle bucket.
Telemetry.
Decreasing acceleration in preparation for maximum dynamic pressure. Great views looking aft towards Cape Canaveral.
Vehicle is supersonic.
We're throttled back up to full power. We're out of the throttle bucket and we're supersonic. Now from here on, even though velocity is rapidly increasing, the atmospheric density is decreasing. And that's resulting on less loads on the Falcon 9. And you've heard the call out, we're through max Q, so the loads are now decreasing on the launch vehicle.
MVAC engine chill has started.
That call out says the bleed valve on second stage engine is open, and that's beginning a final chill of the MVAC engine prior to second stage ignition. All's looking good with the stage 1 trajectory. And we've got 3 events coming up in quick succession. We're going to have main engine cutoff, MECO as we call it. The first and second stages will then separate. And then we will have ignition of the second stage engine to propel Falcon 9 into the first parking orbit. Beginning to throttle down the first stage engines to hold 4G constant acceleration. Coming up on main engine cutoff.
MECO.
Stage separation confirmed.
And we've got, as you can hear the cheering in the background, successful stage separation. Second stage is now under power of the single Merlin vacuum engine. You may have noticed some curved pieces of metal come off the end of the nozzle right after ignition. That's normal. These are ground handling tubes.
Following nominal trajectories.
They're not needed in flight. We hear the call out, we're following nominal trajectory. With the left side of your screen, you can see the first stage grid fins. The titanium grid fins have deployed. Coming up next, fairing separation.
Acquisition of signal, PoMonkey.
Bearing separation confirmed.
A nice view from the second stage camera showing successful fairing deploy as Falcon 9 is passing through 110 kilometers altitude. Now we will be attempting to retrieve these new fairing halves with the help of our contracted recovery vessel, HOS Briarwood. Now currently Falcon 9 second stage heading northeast along the U.S. coast. We are sending telemetry down through the SpaceX Bermuda ground station.
Both vehicles continue to follow nominal trajectory.
Now, as we pass 4 minutes and 20 seconds into flight, all systems are go.
Acquisition signal, Bermuda.
As Falcon 9 carries GPS into space.
It's T plus 4 minutes and 45 seconds here into today's mission, and we're currently in the first of 2 planned MVAC burns for satellite deployment. You can see from the live views on your right, the second stage MVAC engine is burning, and there on your left is a live view of the Falcon 9 first stage as it's preparing to re-enter the Earth's atmosphere. At T plus 6 minutes and 18 seconds, you should see on your screen the first stage's entry burn. This is in just about a minute. This burn will last about 30 seconds.
Acquisition of signal, New Hampshire.
And for the entry burn, we relight the center E9 engine on the first stage, and then partway through, we relight the E1.
Both vehicles continue to follow nominal trajectories.
and E5 engines. So we will have a total of 3 M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere. You can see a great live look at that Falcon 9 first stage there as it's coasting back down. Now, the Falcon 9 supporting today's mission will perform this entry burn for the second time, and both fairing halves will re-enter for the first time. This booster previously supported the November 2020 GPS-3 mission, and we're pretty excited to watch today's landing because it marks the first mission we're supporting for the U.S. Space Force with a flight-proven booster. Now, entry burn will start in just a few seconds here. Listen for the call out.
Stage 1 flight termination system is safe.
Stage 1 entry burn has started.
You heard the call out and you can see on your screen, stage 1 entry burn has started. This burn lasts about 30 seconds.
Stage 1 entry burn shut down.
We did have a successful stage 1 entry burn there. And now while Falcon 9
Both vehicles continue to follow nominal trajectories.
While Falcon 9 makes its way back to Earth, you may notice that there are different soot markings on the outer covering of the rocket. You can maybe just see them on your screen on the left there. Now, if you've ever wondered how these markings are formed, the soot is generated when the carbon-based rocket-grade kerosene, or RP1, burns. And since our re-entry occurs engines first, the booster flies through its own plume, which deposits the soot on the rocket there. Now, coming up next will be our landing burn, which will be at T plus 8 minutes and 7 seconds. This will also last about 30 seconds, and it will hopefully land our first stage on our drone ship. Just read the instructions.
Stage 1 is transonic.
Off the Atlantic coast. You heard the call out that stage 1 is now transonic.
Stage 2 has entered terminal guidance.
Now, just 1 second after the start of the landing burn, we will actually have second engine cutoff
Stage 2 flight termination system is safe.
on the second stage on the right. So both coming up in just a few seconds here.
Stage 1 landing burn has started.
You can see that stage 1 entry burn.
Seco 1.
Landing burn. And Seco 1. There's the first stage coming in.
Landing legs are deployed.
Nominal parking orbit.
Stage 1 landing confirmed.
What a beautiful view of that first stage landing. And we did get a confirmation from our second stage of a nominal orbit. You can hear the cheering in the background. Everyone's really excited. We did, again, have a confirmation of a nominal orbital insertion. And of course, we saw that beautiful landing of our Falcon 9 first stage on our drone ship, just to read the instructions. And there you have it. You've just witnessed Falcon 9's 19th landing for this year and SpaceX's 88th overall successful recovery of a first stage. And now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 53 minutes, and then we'll relight that MVAC engine for a second time shortly after at T plus 1 hour and 2 minutes. We'll see you back here
Acquisition
at
signal Newfoundland.
1 hour and 3 minutes.
Expected loss of signal Bermuda and Po Monkey. Expected loss of signal New Hampshire. Expected loss of signal Newfoundland. Acquisition of signal Goonhilly. position signal, Oak Hangar.
LDA. I also say safety already left. They already told me they have no reportable items as well. Seemed like it was a relatively clean count. Though we had the Doppler wind issue. I overheard some chatter on the bids, but it sounded like that came back up as well. I don't have any items to pass along on the bottom line. The weather turned out to be in our favor, which is great, but great communications. LDA. Okay, how about now? Rock, this is LDA. Can you hear me?
signal Green Hilly and O'Connor. acquisition of signal, Diego Garcia. Expected loss of signal to Eco Garcia.
sat there and looked at the rockets from Mars, and you just boggled the mind and mind and mind and mind. And the technology caught up to them.
Acquisition signal, Tasmania.
MVAC engine chill has started.
Welcome back to the webcast of the Falcon 9 mission carrying GPS-3 Space Vehicle number 5 for the U.S. Space Force. We've had a nominal mission so far. Falcon 9 lifted off on time at 12:09 p.m. Eastern from Cape Canaveral Space Launch Complex 40. 2.5 minutes later, we separated our first and second stages. Now, the second stage completed its first burn, placing the Falcon 9 and the GPS into the desired parking orbit. As you can see from the timeline at the bottom of the screen, we're approaching the second burn of the MVAC engine, and that will carry Falcon 9 and GPS to the orbit needed to deploy the satellite. Now, the burn's coming up in about 20 seconds. Currently, Falcon 9 second stage, we're chilling in the engine, getting ready for ignition. We're settling propellants.
MVAC ignition.
And we've got ignition of the second stage engine. Niobium nozzle starting to glow red hot as normal. Now this burn is planned to last 44 seconds. And during that time, we're going to add 2 kilometers per second to our velocity. You can see the gauge on the bottom right of the screen showing stage 2 is quickly gaining speed. That 2 kilometers per second will equal out to 7,000 kilometers per hour being added to our velocity. And this is going to change the orbit from a 400 kilometer apogee to one with a 20,000 kilometer apogee. Throttling down the engine, preparing for shutdown.
MVAC shutdown.
Okay, we've got shutdown. We're waiting to hear from the guidance officer.
Nominal orbit insertion.
And we've got a nominal orbit insertion. Now, as a reminder, the GPS satellite is still attached to Falcon 9's second stage. Payload deployment is timed to occur once the orbit takes us into range of one of the Space Force satellite ground stations, one in Hawaii, one in California. Once we reach this point, the Falcon 9 flight computer will command release of the GPS satellite. Now, currently we're getting data through Tasmania, so it's going to take us about 25 minutes until the orbit climbs into sight of the ground stations. Satellite separation will then occur at approximately T+1 hour and 29 minutes. Now, while we wait for this next milestone, I have a short video from the satellite manufacturer Lockheed Martin. It'll highlight some of the new capabilities of the spacecraft. Take a look, and we'll see you back here at T+1 hour and 28 minutes for satellite separation.
Expect loss of signal, Tasmania.
technology caught up to them.
Acquisition signal, Hawaii. Acquisition signal, Cook.
to our launch coverage for the GPS-3 Space Vehicle 5 mission for the U.S. Space Force. If you're just joining us, we had an on-time launch at 12:09 p.m. Eastern, followed by a successful ascent, stage separation, first stage landing, and 2 second stage engine burns. We have just one more major milestone coming up to complete today's mission, which of course is the deployment of the GPS-3 satellite from Falcon 9's second stage, which will happen here in just under a minute at T+1 hour, 29 minutes, and 20 seconds. Currently, we are in view of the customer ground stations at Hawaii and California, which are necessary to reach prior to deployment. Now, in the 20 or so minutes since we've been coasting, we have increased quite a bit in altitude from our last burn, from about 420 kilometers now all the way up to over 4,000 kilometers. You can see those beautiful live views from our second stage. And let's listen in to hear that call out and watch for GPS-3 separation from our second stage here in just a few seconds.
Payload separation confirmed.
You can see in that beautiful video and heard the confirmation that we did have a successful payload deployment there. And for those watching, you are witnessing a successful deployment of the GPS-3 Space Vehicle 5. And with that successful deployment, that now brings our webcast to a close.
Great views from the camera on the second stage of Falcon 9 as we watch GPS-3, number 5, heading away from the vehicle. It's on its way to do its mission. We'd like to thank the U.S. Space Force for entrusting us with today's GPS-3 Space Vehicle 5 mission. SpaceX is one of 2 certified providers for national security space launch missions, and we're proud to be able to offer reliable, cost-effective launch services to the U.S. Space Force. We look forward to supporting the next GPS mission that's targeted for liftoff next year. Also, we send thanks this afternoon to the Space Force's Space Launch Delta 45 for range support. SpaceX will be observing Juneteenth this weekend, a historic holiday that commemorates the emancipation of those who had been enslaved in the United States. And we would also like to wish all the dads out there a happy Father's Day. Thanks for tuning in and have a great weekend.